the first one says, determine the degree of the Maclaurin polynomial required for the error in the approximation of the value cosine of 3. And we want that to be less than 0.001 according to Taylor's theorem or Lagrange error bound, right? So I'm going to write out the theorem to start, okay? Or our little funky new formula, right? So remember, you have to have it memorized. I'm not going to have it there for you, so you kind of need to remember the structure of it for the most part. So it's r sub n of x, the absolute value of it, was less than or equal to the maximum value of the next term, right? The n plus 1th term, evaluated as some value z, which is the biggest value of it, over n plus 1 factorial. And then in this specific case, okay, our x value that we're substituting in is 3. And then because this is Maclaurin, instead of subtracting another number, because there's no about a c value, our c value is equal to 0. So I'm going to use 0 there, n to the n plus 1 power. And then they say they want that to be less than 1/1000th. Is there a better way to write 1/1000th rather than that decimal point? Let's pretend. Yeah, if we pretend for a moment we aren't going to have a calculator or a fancy calculator, we'd want to write it like that. Okay. Okay, so let's see what we can do to manipulate that a little bit. Let's talk about this piece here for cosine. What is the biggest that maximum value can be for cosine? What did we learn yesterday? It's going to be 1. So that basically disappears because it's a 1, right? So we know we're going to substitute 1 in for this. So, and then this is just going to be 3 to the n plus 1 over n plus 1 factorial. We want that to be less than or equal to 1 over 1000. Actually, I take that back. It's not less than or equal to, it's just less than. I don't know where I got me. It's on this end, it's less than. The remainder is less than or equal to, but we want it to be strictly less than 1 over 1000. Okay. We could probably manipulate that and get some decimal points going on. But what I'm going to do is we're going to practice some algebra. I'm going to make it look a little bit nicer. Okay. So I'm going to multiply this. Ooh, that's not what I meant to do. I'm going to multiply. Why is it erasing? All right, I'm going to multiply both sides by the 1000 to get it to the other side. And then at the same time, I'm going to multiply by n plus 1 factorial. So I would have 1000 times 3n plus 1 less than n plus 1 factorial. All I'm doing is some algebra just to get it to manipulate. I want to get rid of that. My goal is to get rid of the 1 over 1000 fraction. How would I get this to the other side with the other ends? Yeah, we're going to divide. So 1000 less than n plus 1 factorial over 3 to the n plus 1. Okay. If you like your ends on the left versus the right, I don't know if this makes the number easier for you to see. You could, this is not a necessary step, but we could move it like that. But remember, the alligator is eating the n plus 1, so I want to keep it eating the n plus 1. All right, so basically what I am now looking for is I want my left side to come out to be a number that's bigger than 1000. Okay, so I'm going to do some experimentation. We did this when we did the alternating. We experimented with some n values. Okay. All right, so what I'm looking at is I'm looking at what n plus 1 is equal to. Okay. And we're going to kind of come out with, we're going to make a little chart and this, so we're going to make the value and then actually just going to find the values and see if they're greater than 1000 or not. All right, so let's take a look at, so I'm going to plug in, I don't know, let's start with let's try 8. So I'm going to go 8 factorial divided by 3 to the 8th. Am I anywhere close to 1,000? I did not do very good, did I? 8 is definitely not the n value. But if you wanted to, our n plus 1 is 8. It was like 6.1 something, right? Yeah, 6.14. Okay. All right. Which is not where we want to be. So what do we want to make our next guess? What do you guys want to put? 10? Okay, let's try 10 and 10. 13! All right, let's go a little bit less than 13. Let's try 11. Okay, I don't want to get there too fast. 11? Is 11 better than 8 was? So n plus 1 equaling 11 was like 225 point something, right? All right, I'm going to go 12. Are we getting closer to 1,000? Yeah, so the idea is you're just going to kind of guess and check and experiment with the numbers a little bit. So n plus 1 equals 12 was like 901 point something. All right, let's try n plus 1 equals 13. Are we now over 1,000? Yeah, so now we got what we wanted. Okay, so now that's like 3905. Let's try that. So it's 3905. Okay. Which this is definitely greater than 1,000. All right. Here's the deal, though. This is what we get when we have n plus 1. So what's the actual n value? $12, right? So I really put 12 in. The n plus 1th term ended up making it 13 as my exponent. Okay. So if my n is equal to 12, then we will get an answer that is over 1,000. Okay. And that, notice it made that jump really fast. So you want to kind of, for your work, I would want to see a little bit of experimentation going on. What are the values that are kind of surrounding 1,000 and write that work down. Okay. All right, makes sense? Probably easier than what we did yesterday. Okay. So going from the formula to the first step. Okay. Do we understand where I got the 3 minus 0 part? This is the x minus c. Okay, part of the formula, part of our Taylor polynomial, right? So they specifically gave us this x value. They did, because it's Maclaurin, what is automatically the c value? 0. So that's what I put in there. Does that make sense now? Okay. The only other thing that really is the change is this guy right here, right? So what's our function? Cosine. What is the biggest cosine can ever be? 1. So I have like an invisible 1 times this. Does that make sense? The next line down? I manipulated some algebra to make it easier to look at. Could I have left it like this and experimented there? I could have. Okay. If I wanted to. If I didn't have a fancy calculator, I probably would go with where I did with the greater than 1,000. Okay. I just kind of make sure we review some good algebra. Okay. All right. Any other questions on that one? All right. Here comes the next one. I'll give you a minute if you want to scribble any of it down. the plus sign. 1 plus x squared plus x cubed plus x to the fourth. Okay, we ready? Okay, so it tells us we've got fourth degree, right? That's what fourth order means. It's another way to say fourth degree approximation. It gives us a domain. Okay, so we have to be less than 0.75. And then they were nice enough to give us the series or the polynomial, right? We didn't have to find that on our own. And then we're supposed to use Taylor's theorem or the Lagrange error bound to estimate the smallest possible upper bound of the error. Okay, so we're going to look at our remainder again. So same remainder formula. Ooh, not z, x. All right, and we want that to be less than or equal to the max, which is going to be, so if I'm at degree, or I'm at fourth order or degree 4, what does my formula have to have? 5, right? So the fifth derivative evaluated at z over 5 factorial x to the fifth. Okay. So we got to talk about the biggest that e could be, because isn't e is the function, right? So the max the function can get. Well, the max the function can get is e to the 0.75. So we're going to use that now, because all I did is I took what they wanted, the upper bound of the domain. It's going to be less than that number. So I know if I put that number in, that's the biggest my e could get. Does that make sense? All right. So I know the biggest I could get here is e to the 0.75. All right. The 5 factorial comes from the formula. And then I want to plug that value that we're evaluating in. So that 0.75, that biggest value to the fifth power. All right, and this is still less than or equal to, less than or equal to. All right, put it in your calculator. So you can put it into Desmos, put it into your calculator. Okay, 0 point what? Yeah, you even stopped at the same place I did. Good job. Great minds think alike. All right, so that, again, I think that's probably easier than what we saw yesterday. Okay. So those are the two I wanted to show you. Everything else should be pretty self-explanatory. I think I gave you one Taylor, one Maclaurin, one, and then one of each of these. Okay. We did do f to they're both n plus 1, right? Because this one started at, or stopped at where? 4. So this is still n plus 1. Okay, does that make sense? Okay, it doesn't matter if it's Taylor or Maclaurin. Oh yeah, this one would have been Maclaurin because of the look at it doesn't have, we're not adding anything to it, right? In there. So even though it didn't state it was Maclaurin, it's like saying x minus 0, x minus 0 squared, and you get it from just looking at the series. Had it been x minus 1, I totally left that off, and thank you for pointing that out, x minus 1 squared over 2 factorial. Had it been that, we would have done 0.75 minus 1 in there. Does that make sense? Why I left off, I didn't put anything in there, is because it was a 0. Okay. Are there any other questions? Up here?
Yeah, because you didn't do the x minus c.
So the 0 is assumed, right? Because if our basic structure of a Maclaurin polynomial is you have whatever your number is, right? Plus x minus c to the first, plus x minus c squared over 2 factorial, plus x minus c to the third over 3 factorial, and so on, right? So because I look at this, that's not set up. So if I'm going to rewrite that, I would write it as 1 plus x minus 0 to the first, plus x minus 0 squared over 2 factorial, plus x. Does that make sense where I got the 0 from? No. We're using the Taylor's theorem, which is the same as the Lagrange error bound. So don't mix it up, okay? Say it again, Erica. Because it did not give you a value in here. If it had been 1 plus x minus 1 to the first plus x minus 1 to the second over 2 factorial plus x minus 1 cubed over 3 then that's Taylor. Does that make sense? Okay. You're going to find a lot of them go towards Maclaurin. Okay. So there's a lot, and that's like you jump for joy when you see Maclaurin, right? So because we know we don't have to mess with that minus whatever. It's just a 0. Okay? Fallon. Yeah, I just recorded it. Okay. So you've got, I'm going to put it up right now because I have to have it for Jocelyn and Marissa. So, all right. Any other questions? Okay. Why don't you guys open up Otis? We have till 58. So you've got like 20 minutes. In theory, you should be able to do 4 of them in 20 minutes, right? If you want markers, you can do boards. Okay. The board markers are back here, or you can do your seats. Okay, you pick. Okay. If you like thinking on the board, think on the board. Okay. I'm gonna shut the recorder off. But if you need my help, let me know. Okay, we can still talk about it.